Good day, grade 10s, and welcome to the Thursday session of Physical Sciences. All right, so today we are going to do the last little bit of content about waves. And I know yesterday I had so many of you going, but ma'am, we need more examples. Ma'am, we need more of this. Ma'am, what about that? Okay. I saw that yesterday, okay? So today we're going to do tons of examples. Now, the moderator also yesterday at the end whispered in my ear that some of you guys are very, very interested. You saw my video behind me, and today we haven't got that on because then the slide that you guys can see is much bigger, okay? But I thought I would answer you guys because I very strongly believe that if you don't really know who I am, then how are you supposed to trust me? Okay, so I do appreciate the comments about it. Okay, the moderator made the decision not to post it simply because it's not work related. Okay, and that's the deal, you know that. Okay, but I thought I would answer it today. We'd start off with that. Okay, so let me just see, guys, you know the deal. You need to go find the live Q&A. You need to tell me that you are here. All right. So I have a horse. It's the one in the picture behind me. His name is Danny, and I've had him now for 10 years. Okay. And Danny and I take part in shows, and he's a very, very good horse. And so all the ribbons that you guys saw behind me are ribbons that him and I have collected over the last 10 years. Okay, and my absolute favorite friend, I get along with him really well. Yeah, it's just like having a friend for 10 years. I think you get to know them really well. Hey, all right, so I thought I'd start off by answering that. Then I also want you guys to have a look in the Q&A, please. I have again sent the drive, okay? It's the same drive as all of the other times, okay? I haven't changed the drive. The link for the drive is the same and the drive is the same, okay? So if you already have the link, you don't have to download it again. And then I've also given you the Teams link for tomorrow, okay? And again, guys, you don't have to panic to get it now. You are more than welcome to get it at the end. I will repost both of these links. Okay. Hello, hello. I have a Miss P and I have a Cordy Marie and I have a Jared. Oh, all my favorite faces. You guys are actually all my favorite faces. Really. Like, I feel like I'm getting to know you and getting to know your personalities. Okay. All right. As I promised yesterday, thank you. I can't remember who reminded me that I still need to look at that homework problem. So I thought we'd start off with that. Okay. So the question I gave you, one end of a slinky is tied to a desk. The other end is shaken by a learner and it produces transverse waves in the slinky. The waves have a frequency of 0.8 Hertz and a speed of 24 meters per second. So those are the facts that we are given. Then they asked us, firstly, to calculate the period of the wave. And secondly, they asked us to calculate the wavelength. All right. Now, in terms of wavelength, we do have two equations that we can use for it. I just found that using the speed and the frequency is much easier. Okay, so let's see. I did them for you step by step. Nate are here, Callum are here, Pax are here, Erin, my man, my girl. Oh, Miss P, I know. When I was growing up, I also wished I had a horse too. I only bought this horse when I was an adult. Okay, so yes, I also went through stages where I wish I could buy a horse, or I wish my parents would buy me a horse. Okay, but because I felt so passionately about it, there are lots of other things that I give up. So I don't go out for dinners. I don't live in a fancy house. I don't drive a fancy car, okay, because horses are quite expensive. So that's my priority. Anyway, let's get going, shall we? Matt. Oh my claw. Ashley. Ah, you guys are here. Oh, now I'm feeling better. Now I can teach people. All right. So let's look at calculating the period of the wave. So, period has the symbol T. We know that period and frequency is related by this expression. We can get the period if we go 1 divide by the frequency, or if we have the period and we need to calculate the frequency, we go 1 divide by period. Okay, so I have the frequency there, 0,8 hertz. I substitute and I get an answer. So that is a very, very easy question, okay? Guys, it really is that simple, okay? Sometimes they're a little bit sneaky when they ask you for period and they do it on a graph. I will deal with that tomorrow, okay? I promised you tomorrow I will show you 2 questions that they like to ask in terms of waves, okay? And so I'm going to show you how to approach. Hello, Tyler, welcome. Okay, I'm going to show you how to approach those tricky questions, where to start reading, where to find the information. Okay, all right, so this was really, really, really easy. Jenna, are you a newcomer? Cool. Yay, we're still growing, guys, like 3 weeks in and we can still have new people. Welcome, Jenna, that is awesome. Okay, so this is very, very easy. All right, the next one we are asked to calculate the wave length. All right, now you could use the period, but then it gets ridiculously complicated. So I chose to use wave speed equals frequency times wavelength, because I get given the frequency and I get given the speed, okay? Then I substitute into the equation. I need to get wavelength on its own, so I divide both sides by 0,8, okay? And then this is simple calculator work. And 24 divided by 0,8 gives me 30, and its wavelength, so it is in meters. All right, guys, so those are not that scary. They are very doable, okay? You must just make sure that you read your questions very carefully, very, very carefully. Use your highlighters, use your pencils, make notes on your question papers, okay? Even in your answer sheet, write down all the variables that you get given. Okay, so guys, those are easier wave questions. Like I say, tomorrow I will show you the harder ones, okay? But I'll help you navigate your way through, so you really, really don't have to worry. Okay, we're all good. I hope you guys tried it and I hope you guys got it right. Hey, Ali. All right, so guys, let's get going with today's work, okay? So today we're going to look at energy and waves. So I'm going to teach you a new equation, but you don't have to panic, okay? Because it has a constant in it. The constant is on the information page. The formula is on the information page, okay? Like really, really easy. All you need to know is which parts go with which part of this equation. Okay, let's have a look at the theory. Before I start, we are on Oxford, page 102. And you guys know my study and master doesn't have page numbers. So it's round about roughly-ish page 125. Now, for those of you who have textbooks that you struggle with, for those of you who don't have textbooks, please remember that Snaplify, 2 P's, Snaplify, has got the Oxford, the Study and Master, as well as the Mind Action series. And those textbooks for the rest of the year in electronic copy is free, okay? So you download the app, you create a profile for yourself online, you click which ones you want to download, and then it downloads it to you online on your app, and then you can use them from there. Now I also, hey, Miss P got it right. Mercy, the answer for period is 1,25. Sorry, I'll go back. Okay. Then the other thing I want to tell you guys on Snaplify, there is a couple of books called the Zoom series. Okay. Now the Zoom series is also produced by Oxford. And what I've seen in the Zoom series is they actually have little interactive like links that you can read through a topic and you can click on it and it actually shows it to you as a little animation. So for those of you who are more visual, okay, and who need like the pictures and stuff, I strongly recommend the Oxford, but the Zoom series, okay. Again, this is also on Snaplify, okay, and also free until the end of the year. So really, guys, use this opportunity, okay, if at all possible, and get that for yourself. Okay. Right. So, photons, quantization, quantums, quanta, all these new words. It's okay, right? And I know how much you love definitions. Come on now. Yay, definitions. Okay. So we're going to go through the theory. We're not going to spend too much time on it. I want to get to the application of this, okay? Because this section in waves is the one that you get most of the questions on, okay? So quantization is a quantity that comes in an amount that you can't make smaller. Now, there's a couple of quantizations, for example, the charge on an electron, okay? The other one is the energy of a photon, okay? Now, what's a photon? Don't worry. The amount, the smallest amount, okay, of a quantity that we can't break smaller is called a quantum. In chemistry, okay, an element is broken down into atoms. Atoms is the amount that we cannot make smaller, okay? So in terms of chemistry, the quantum would be the atom, okay? When we work with light and energy, the quantum is called a photon, okay? I know this is confusing. Let's just talk about it again. In chemistry, we have elements, okay? We have matter. And all matter can be broken down into small bits. And those smallest bits are called atoms. But we cannot break an atom down further. So the quantum of matter, the smallest amount of matter, is called an atom, okay? So a quantum is an indivisible amount of a physical quantity. It just goes back there and you know, here and like back and forth, okay? Erin, I think that's really cool. The boys, click on the form. Okay. So the quantum of light is called a photon, right? More than one quantum is called a quanta. This is a Latin way of making things plural. Okay, don't panic about it. All right. So the important stuff. A photon is a quantum, the smallest amount, quantum, the smallest amount of electromagnetic radiation waves, it has zero mass and it travels at the speed of light. Okay. So you guys remember yesterday when we did electromagnetic radiation and there was the electron going in a straight line and then the electric field and then the magnetic field, okay? So all of that radiation, all of those waves, that electron that's accelerating, okay, gets condensed into this one concept, okay? Because we are less interested in what makes an electromagnetic wave tick and more interested in what we can do with it. And the big thing that we can do with electromagnetic waves is transfer energy, okay? The problem is that electromagnetic waves that have very high frequencies have insane amounts of energy, okay? Insane amounts of energy. And that can be dangerous. And that's why we need to know how to calculate energy. Okay. The energy of a photon increases as the frequency increases. Okay. In maths, we could say E is directly proportional to F. This mathematical relationship is not one you are expected to know. Okay. Now, what follows on this, the equations and the ideas that follow on this, you are not going to repeat in grade 11, but one of the last sections in grade 12 in physics
Hi everybody, teacher will be back in a moment. Please just give us a minute to quickly work out these technical difficulties. We'll be back just now.
Sorry about that, guys. Oh my goodness. Better link that one too. Sure. Must be the weather. Those of you who are in Cape Town. Guys, I'm just waiting for the Q&A on my side to re-enable, okay? Give me a second. Sorry, guys, now you're seeing all the other stuff and you're seeing the stuff behind the scenes. Okay, let's try this again. like I was saying, I'm pretty sure it's the weather. I don't know about the rest of you guys, but we have got crazy wind on the side. Almost. Maybe. And I'm back. Woohoo! Now, of course, you seeing this, oh, I'm seeing this in like backtrack mode. Oh my goodness, that was terrifying. Just waiting for the Q&A, guys. Okay, sorry, I'm back. Ruben, yes, E equals H times F. Quarks or smaller than atoms? Yes, Matt, you are not wrong. Yeah. But now, Matt, you are talking in the realm of stuff that my brain has never fully been able to grasp. Okay? We have bosons, we have quarks, we have antiquarks, and then there's another one. Okay? Like I say, I can theoretically give you, with enough studying, the information on quarks, okay? But my understanding of it is limited. Okay, the science and the maths that you need to deal with that is insane. Okay, so sometimes I've made my peace with it. My brain's not quite imaginative enough for the science that you need. Okay, so yes, Matt, you are correct. Yeah, it's a hard system. Okay, Ruben, you've got the right equation going. So, you don't need to know this formula, okay? This mathematical relationship. And the formula is given on the information page. You just need to be able to use it, okay? Right, here we go. The formula is E equals HF, right? E is for energy in joules, which we shorten to a J. H is a constant. 6,63 times 10 to the power minus 24 joules seconds. You don't need to remember this value. No, Anonymous, you don't need to know quarks. Don't panic, that's not even in the matric syllabus. Okay, so H is a constant, 3,36 times 10 to the power minus 34. This constant is given, you do not have to memorize it. And F is the frequency of a wave, and it is given in hertz. Okay. Now, this formula is on the information page. You don't have to memorize it. You have to be able to use it. And that's what we're going to focus on today. Cool? Now, before we get to applying this, sometimes you don't get the frequency, but you get the wavelength. And you'll remember from yesterday that if we have frequency, we can calculate wavelength. And if we have wavelength, we can calculate frequency. So we have a secondary formula that we can use if we don't have frequency, but if we have wavelength. Okay, now H is called Planck's constant, Mr. Plancky Planck. Okay, again, on the information page. Right, guys, you must just be able to apply. Let's look at the secondary equation where we don't have F, but we have lambda. Okay. Again, constant on information page. Don't have to remember it. Fantastic. So, if we have wavelength and we don't have frequency, you've got one or two options. You can either use the wavelength and the speed of light in a separate equation to calculate frequency, and then use the previous equation. Or you could use this. Energy, C, speed of light, H, Planck's constant, divide by wavelength. Okay. This formula is also on the information page. And here we have two constants. We have C, the speed of light, and H, Planck's constant. Okay, so E is still energy of a photon. H is still Planck's constant, 6,63 times 10 to the minus 24. But now we also have to substitute the speed of light. Don't panic, it's on the information page. Mercy, I see your question, I'll answer. Yes, they have to give you Planck's constant. When do we learn about Avogadro's constant? That was term 1, Aaron. Mercy, J dot S means joules times second. So J dot S is the unit for Planck's constant. You don't have to worry about it. Okay. Right. So we have those two constants and then we have wavelength. And important, wavelength is in meters. Okay, guys. Whoops, sorry. Okay, so we've got two formulas that we can use when calculating energy with waves. Okay, right. So let's look at an example. I think I've got 1 or 2 in here, okay? And then I've got like 4 at the end for you guys to practice. Okay, cool. So, the first example. We are asked to calculate the energy of a photon of blue light. They give us the frequency. They say the blue light has a frequency of 6,4 times 10 to the power 14. That's a lot of zeros, hertz. Okay. We have to calculate energy. We have frequency. So we use E equals HF because we want to calculate energy and we have frequency. We substitute H on the information page. You'll always get it. F comes from the question, okay? And you put this into your calculator. All right. Make sure you know how to use the exponents on your calculator. You're going to do them a lot for waves, okay? A lot. So make sure you can effectively type this into your calculator, right? So I got the energy of a photon with a frequency of 6,4 times 10 to the power 14 is 4,24 times 10 to the power minus 19. Okay, and energy is in joule. So that's a pretty simple one, hey? Not that bad, no? Okay. Now, it is also possible for them to give you the energy and ask you to calculate the frequency of the wavelength, okay? So let's look at what the maths for that would look like. So here we are asked to calculate the wavelength and we are given the energy. Then they're quite mean and they say, well, identify the type of EM wave. Okay, sure. Oh, okay, I need to teach you guys about Avogadro's number. Got it. Can I spend some time on Avogadro's number tomorrow? Will that help? Okay, guys, duly noted. Miss P, yes, you could write the formula like that. I give you the formula like it is on the information page. Okay. Yes, with the lambda sign. So that is C equals frequency times lambda, but that's only if you've got lambda and frequency or speed. Okay. we are now not working with the speed, the wave speed equation. We are now working with a wave energy equation. So you still need to page on a little bit in your textbook to find this work. Okay. Right. Must we know H or memorize the number for a test? No. Planck's constant is given. The formula is given. Okay, so now we get to what formula to use, right? So we have to calculate wavelength. You could use the previous equation and calculate the frequency, and then use the frequency to calculate the wavelength, but that is a very roundabout way of getting there, okay? So I would go straight to this equation, okay? Straight to this equation. And again, this equation is on the information page. They've already dealt with the fact that I don't have frequency by going C divided by lambda. Okay. So I figured that the maths here might terrify some of you. I know that there's some of you in here that will go, oh man, maths is easy. Okay. So what I did is I did the substitutions and then I also showed the maths. So I apologize if the maths is very easy for you, okay, and you didn't need me to do it. But I know for myself, if I have the unknown under the line, it gets a little bit terrifying. Okay, so I've got energy and C and H are constants. So I substitute the energy. C, given on the information page, C equals 3,0 times 10 to the power 8. This is the speed of light. H, Planck's constant, 6,63 times 10 to the power minus 34. Okay, and then I have H. So now we need to manipulate so that we can get lambda on its own. Now, I don't know about you guys, I don't like fractions, like I hate them. So I get rid of this problem here first, okay? So I multiply lambda. So I end up with lambda times 1,9 times 10 to the power minus 18 is equal to speed of light, 3,0 times 10 to the power 8 times 6,38 times 10 to the power minus 34. Okay, that's there at the top. All I did is this thing underneath, I multiplied both sides with lambda, okay, so that I don't have a fraction. But I still want lambda on its own. So to get lambda on its own, this 1,9 times 10 to the power minus 18 is multiplied by lambda. So if I want to get rid of lambda, I have to do the opposite. I have to divide. Okay, and so I get that lambda is equal to C 3,0 times 10 to the power 8 times H 6,63 times 10 to the power minus 34 divide by E, the energy, 1,9 times 10 to the power minus 18. Okay, so this is then what I put into my calculator. You are welcome, obviously, to plug this into your calculator and get a value, okay, and then calculate further. I prefer to use my calculator as few times as I can, okay. I am famous for typing stuff in my calculator wrong. Okay, Miss P. Miss P, do you have access to the drive link that I sent you earlier? E2, this is like page 120 on the Study and Master. Okay, Miss P, just tell me whether you have, if you can use the Google Drive link, because then I can put notes in there for you. Okay. All right. So guys, you plug this into your calculator and ta-da, you have an answer. But now we haven't answered the whole question. We need to identify the type of EM wave. Okay, let me just catch up with you guys a little bit. Okay, Ms. P, what I want you to do is go check in the Google Drive. I'll make sure I've got the link for you. Okay, I've explained this really nicely in a Word document. Okay, right. So, before I give you a couple of things to try for homework, we need to figure out what type of EM wave is this. So, we have to look at the spectrum. Okay, so I pulled the spectrum in. Yes, Tyler, you are correct. Tumelo, you need to go to week 4, and all the stuff for this week is in week 4. If you guys can't get into those folders, if you need me to pull the files out of the folders, just let me know tomorrow, please. I don't mind doing that. I'm glad, Miss P, I'm glad. Okay, so Tumelo, just go double check on the drive, okay? Let me finish this question, I'll pull the drive over. Let me do that. Okay, so we have to know what type of wave this is, right? Now at the bottom there, I know it's very blurry. At the bottom there is wavelength and there is frequency. We have wavelength, so we look at the bottom. We've got something around about -7, okay? So we have to go find -7. Here's -6 and here is -8. So -7 is roughly about there. So it has to be a UV ray. Okay. So the wave falls in the UV range. Okay. Now this is quite a mean question, this last bit of the question to ask. Okay. Like quite bad. Okay. It would be very bad because it requires a lot of thinking. Okay, so here's a couple of questions for you guys to try. Okay. While you guys jot down the questions, I am sending the link for tomorrow your way. I am also sending you the link for the drive. Dunk. Okay. The moderator will okay them in just a moment. Okay. So guys, read carefully what you get given and what you get asked to calculate. Okay. You've got those two equations, right? So I want you to use them, only those two, to calculate these 4 questions. Okay, so tomorrow I'll start off with these. These are nice. And then I will introduce you to the mean questions of waves. And I will show you how easy it is if you just know what you're looking for. Okay, guys, I'm going to give you a minute more to get these questions down. And then I'm quickly going to run you through what the Google Drive looks like and where you're supposed to be finding stuff. How will we know what formulas to use? You use E equals H times F, or E equals CH at the top, divide by lambda, the wavelength. So you see what you have. So here you have energy, and you need to calculate. Oh, no, you have to calculate energy, and you are given frequency. So you use the equation that has frequency in. Here, you are asked to calculate the energy from wavelength. And so you use E equals CH at the top, divide by lambda. Okay, so every single time, check what you are given or what you have to calculate, right? And use the appropriate equation. I'm quickly just going to pull the drive in here so you guys have half an idea of what it looks like. Okay, now obviously I'm stuck. I can't see my Q&A anymore. Anyway, okay, so very quickly. Week 2 was when we started. So in week 2 is my lesson on getting to know the periodic table. Week 3 was last week, okay? Week 3 has got in the balancing, okay? So that's what week 3 looks like. And then this week is week 4, okay? And today's stuff is here under the 23rd, and there's the links page, okay? And then I will add tomorrow's stuff in here in just a little bit. All right, guys, thank you so much for joining me. You know I love to teach you, okay? Thanks so much for being here. I will see you guys again tomorrow. And like I say, don't panic. I will talk you through it beautifully, okay? I promise. All right. Guys, have a fantastic day. Good luck in maths if you're going. I hope you are. You need maths or science. You see, lots of calculations. And I will see you guys again tomorrow. Okay, bye.